They want to build 10,000 Starships per year. And yeah, if you look at what is the steady state launch rate that would be required for that production rate? And it comes out to like one launch every 2 minutes, as long as the rocket is large enough to speed the dust up to the velocity of the rocket exhaust, then the dust goes globally around the moon. The only way we can mitigate it is by determining how much damage is acceptable. 10 years from now, it'll be cheaper to build a large data center in space than to build it on the Earth, largely because of the cost of delay from permitting. A very large data center might make $20 billion of revenue a year. And so a 2-year delay could be a $40 billion loss. If you only have a few people with the ability to produce 1 billion times the Earth's economic production, they could buy the politicians, they'll have the military they need. There's no way democracy survives in that situation. Fully autonomous luxury communism. Have you heard that term before?
Disruptors and curious minds. I'm Jeremy. This is Mark.
Be disruptive. Stay curious.
And keep thinking on paper.
Dr. Philip Metzger, welcome to the show. Thank you for thinking on paper with us. It's an honor.
My pleasure to be here. Thanks for inviting me.
So to begin with, where does NASA fit into the future of space exploration? Does the economic future and validity of space economy need NASA?
Yeah, that's a great question. And the answer is a little complicated. I'll just try to hit the couple of main points. Number one is right now, it's definitely crucial. As we're trying to move civilization beyond Earth, there really aren't very many viable business cases beyond the planet. Everything is centered around the customers that are on Earth, and it's difficult to utilize resources that are outside of the Earth economically. I know that's going to change, but at this present time, the companies that are trying to develop those capabilities really depend on NASA funding and European Space Agency and JAXA and the other national space agencies to fund this work, to develop the technologies, and also to provide some initial contracts for cash flow to help the companies get started. Now, the other half of that is I do think it's going to change. I think NASA will always be relevant. I think that there will always be a role for the public to do things that are not profit-oriented, that are for the public good. But I think that the amount of space activity in space is going to grow so gigantic that it really will dwarf what the governments are able to put into space. So right now, NASA gets about $20 billion per year in revenue. in tax money. But I've done projections that show the space economy is going to be in the range of $50 to $100 billion within about 50 years. So I think NASA will have a smaller role in the future.
Does SpaceX tip the needle towards NASA being more important or less important?
Well, SpaceX is an example of that movement toward commercial space, which is going to have a much larger cash flow. Like, for example, out of the money that I pay every year in taxes, like 0.4 of 1 penny out of every dollar goes to NASA. And then the amount of money I pay in taxes is just a small fraction of the total amount I spend on everything, houses, cars, everything. And so when you look at the massive scaling of consumer economic value, it really dwarfs what NASA is going to receive through tax money. So as companies like SpaceX do develop business cases like Starlink, and eventually launching AI servers into space, and eventually doing manufacturing on the moon, then that commercial scaling is going to come into play.
Mark mentioned we have a book club. We're reading Space to Grow right now. And one interesting piece in Space to Grow was this, a lot of economic principles in here. And one is the stag hunt game. Could NASA be this enabler of trust and coordination to help us move to more stag hunt, hunt more stags than hunt rabbits by ourselves?
Yeah, that's a classic coordination problem. For example, if you want to have a business mining ice on the moon to make rocket fuel, and then using the ice to boost communication satellites, you need to have the companies that launch the communication satellites be ready and expect you to dock with them and boost them using this new technology. So they're going to have to create the adapters, and then they're going to have to trust you because you might ruin their satellite worth hundreds of millions of dollars. So if there's no customers ready, then how are you going to get investors to invest in the business? But if they work together and both parties create that capability, then they can do the business much cheaper. They can launch and boost the satellites into final orbit cheaper, service customers on the Earth cheaper. So all parties will profit. So that coordination problem is an important thing that the government can help solve. And the way the government solves it is by providing grants to both parties or to all parties in order to help them develop those capabilities. And then the government becomes the first or the anchor customer to buy those services. And so that enables the companies to get private investment as well to augment their government funding.
And I think we're all in agreement that the NASA could be the catalyst to enable other companies to be potentially be the coordination source, the coordinator of trust, the coordinator of resources, grants, and that sort of thing.
Yes, we're seeing that happen. For example, NASA is providing some funding. I think it's a minority part of the funding to develop the Starship lunar lander. And NASA is also providing contracts to companies like Redwire Space, which is developing lunar rovers and lunar construction, and to a wide variety of companies developing all the different pieces. And when you put all those pieces together, you can get lunar mining, lunar outpost operations, launching and landing on the moon. So they are being a catalyst for that.
Speaking of landing on the moon and putting things on the moon and launching from the moon, one of the most interesting things you've been working on lately is the effect of rockets landing and launching on lunar soil, what that does. Can you walk us through why it's important, what excites you about that, and what we need to know as the lay people on the outside?
Yeah, what I love about planetary science and about engineering for planetary environments is that because the environments are different than Earth, things that we never thought about become important. And this is one of those examples. Because the moon is an airless body, there's nothing to slow down the dust. And here on the Earth, if you took a handful of gravel and sand and, let's say, baby powder, talcum powder, and throw it, what you'll see is the rocks go the farthest, the sand goes intermediate distances, and the dust just stops as soon as you let go. And that's because they have different ballistic coefficients. It's the ratio of the inertial force to the atmospheric drag force. Well, on the Earth, the atmospheric drag is slowing things down. But on the moon, there is no atmosphere except for the rocket exhaust. And so it speeds everything up, and then all that material flies out into vacuum, and there's nothing to slow it down. And because the drag force is more dominant on dust than it is on rocks, it turns out that on the moon, the dust goes the fastest and the farthest. The sand still goes intermediate, and the rocks go the shortest. And the rocket exhaust is traveling at about in the ballpark of 3 kilometers per second. And there are dust particles that are small enough that they get all the way up to the speed of the gas. And so we're blowing dust at about 6 times the speed of a bullet, and it causes huge abrasion and sandblasting damage. It can ruin telescopes or solar panels or thermal control surfaces. It can get into mechanisms and jam the mechanisms. Because the thermal control getting etched by the dust, it can cause the electronics to overheat, have a higher mean time between failure, causing them to fail. And so it is a big problem. Also, here on the Earth, when we have a blast, the effects of the blast are localized because the rocks get sped up the slowest, but they're the ones that travel the farthest. The dust also gets initially sped up the fastest, but it gets stopped immediately. And so that localizes the radius of the blast. But on the moon with no atmosphere, there is nothing to localize it. So every blast on the moon is a global event. As long as the rocket is large enough to speed the dust up to the velocity of the rocket exhaust, then the dust goes globally around the moon. And the only way we can mitigate it is by determining how much damage is acceptable. and land that far away or build landing pads or some other technologies.
Who answers that question?
It has not been answered yet, and that's a geopolitical issue.
Well, yeah. See, if the Falcon 9 was, we transport the technology up to the moon and next month that can happen, the effects of just one launch would be, is catastrophic the right word? Like, what's the word to describe what would happen to the lunar surface?
It depends on a lot of variables. It depends on the size of the lander, because the amount of gas they blow is proportional to the weight of the vehicle. And also it depends on how high the engines are above the lunar surface. So if Starship uses those upper thrusters, that will greatly reduce the problem, not entirely stop it, but it will greatly reduce it. So it also depends on how close your hardware is, other hardware around the landing site. It could be catastrophic for some hardware. If you land too close to some sensitive equipment, you could possibly damage it or destroy it in just one sandblasting event. But typically it's more of a problem where you're wearing the hardware, and over time the hardware will eventually fail much sooner than originally planned.
Kind of like mechanical electrical systems near the ocean.
Yeah, that's a good analogy. Right. Yeah, like I was doing some analysis where I estimated if you have a 40-ton lander and it lands 1 kilometer away from an antenna on the moon, then after 10 launches and landings, the amount of dust blown into those joints from a kilometer away, the amount of dust blown into those cracks will cause the antennas to jam so they can't rotate anymore. Now, that's a very crude estimate because we don't have enough data yet, but that's the order of magnitude that we're looking at. Now, I mentioned earlier sensitive hardware. If you have a sensor that is on a lunar lander and it's going to go up into orbit and it's going to measure something on the lunar surface, let's say this instrument needs to have a resolution of 3 meters per pixel. One sandblasting of that lunar lander, of the instrument on that lander, could ruin it so that it's no longer able to get the required resolution to produce better than existing data sets. So it could be destroyed in just one exposure.
So disruptors and curious minds, you're probably thinking, all right, there's not a damn bit of stuff happening on the moon right now. Why should we be concerned about this? But the way things are moving, you have to imagine the moon eventually being like Grand Central Station, right? And the effects of all the infrastructure that you put up in Grand Central Station are going to have effects. So you can handle this one of two ways. Like you said, there's a coordination. It's like, hey guys, here are the agreed upon parameters for spacing, for, I don't know, location of devices and launch equipment and that sort of thing. And then also, could you look at an additional hardening of the electronics that you put out there to potentially be resistant to some of this dust?
Yeah, those are two important ideas. In order to rely on hardening your assets, there needs to be some international agreements. We already know that space is a damaging environment for technology. There's interplanetary dust. The dust is falling to the lunar surface. It hits the lunar surface at velocities comparable to rocket exhaust or higher. And but it's a very, very low rate that the dust falls in. So the amount of damage is manageable. If you can get your rocket exhaust damage to that level or lower, then you're probably adequate because you're doing less damage than the environment already is. But the problem is, if you're going to be launching and landing regularly and you're going to be close to other hardware, then you can exceed that by millions of times, exceed the environmental damage. So if we want to rely on hardening, then we have to agree how far away are different companies going to land from other nations' hardware, and how much damage are they going to cause, and then what is the acceptable de minimis level of damage. Right now, the Outer Space Treaty says we're not supposed to do any harm to other nations, but that's really impossible. And so we're going to have to agree on what de minimis means in this situation. And then once we've agreed on that, then we can agree to harden our hardware to at least meet that level.
NASA wants to establish a sustained lunar presence. China, 2029, they've said they want to land on the moon. You have Starship in the mix. Multiple private commercial companies, multiple countries. From a global picture, how do we begin to answer those geopolitical questions? How do we not take the divisional political quagmire mess of Earth into space?
Yeah, I wish I had a good answer for that. Unfortunately, it's such a complicated problem, and we don't even understand all the physics yet of how rocket exhaust blows soil. So we can't do simulations to project what the amount of damage will be. We can, I mean, we're doing that, but our simulations have uncertainties like by a factor of 3. So it could be 3 times worse or 3 times better than what we're predicting. Basically, a factor of 10 overall. And so when you have an uncertainty of a factor of 10, it's really hard to get countries to say, okay, I'm going to agree to drawing a line here. What we need to do is send more instruments to the moon to take measurements so that we can solve the physics and we can benchmark our simulations to the point that we trust them and that different nations can trust each other's research. And there are already discussions happening in the United Nations. The Committee for the Peaceful Use of Outer Space has discussed this topic a few times, and they're going to continue to discuss it. But my personal opinion is that there probably will not be any further treaties because of the contentiousness of our world, or the geopolitical fractured nature of our world. And so I think things are going to be hammered out by precedent. Right now, NASA is trying to push for the Artemis Accords. We have 40 some or maybe 50 nations signed on to the Artemis Accords, which go beyond the Outer Space Treaty to try to establish some of these ideas, some of these precedents. But meanwhile, China, Russia, and a few other nations have a competing effort called the International Lunar Research Station. And so we've got 2 different groups that are not coordinating together to try to solve the problem. So I think it's really going to depend on getting back to the moon, working on the moon, and trying to establish precedent, and then try to get that precedent to become international customary law.
In just one question, in artificial intelligence at Thinking on Paper, we speak about collateral damage. We speak about this race for AGI, and there will be collateral damage. The whether that's the knowledge workers, whether that's the copywriters, whoever that may be, the filmmakers, there's going to be some collateral damage. What's the collateral damage of the space industry? Who's going to suffer?
I don't think I've ever been asked that question. So I'm going to try to figure out an answer while I'm talking. I think one aspect is launching can damage the atmosphere. So if your launch rate becomes too high, then we're going to need to somehow mitigate that. We'll have to control the launch rate and use resources in space rather than launching everything off the Earth. I know that will eventually develop, but we're not there yet. So there's going to be a period of time as the launch rate increases, and there'll be some fighting over it, people complaining, people wanting to limit each other's launch rates, countries arguing over it. But eventually that process will create enough economic pressure on the companies to develop the use of space resources, which will lower their launch rates. So I think that's naturally how it's going to happen. Another collateral damage will be, there is risk of military conflict. Right now, we have treaties that no weaponization is allowed to be in space. But there is so much economic importance to the moon. As we hammer out these policies, we shouldn't be thinking about what is the business case right now. We should be thinking about what is the business case for the next 100 or 200 years, because the business case is going to change dramatically over just a matter of decades. And because we can't launch so much through the atmosphere, we're going to be forced to use resources on the moon and asteroids. Elon Musk, for example, has done these calculations, and he's tweeted about it, and he's said the amount of AI that we're going to need to build, we cannot build it on the Earth. We're going to have to put it in space because of the environmental impact. But he also said we can't launch it into space at the rates that we're going to want to do because of the damage to the atmosphere. So he's already talking about building factories on the moon to build the AI on the moon. And that's one application of space resources, but I do think it's going to be the dominant one in the long run. I've done a lot of economic modeling of development of space industry. I've looked at 13 different sectors of space industry where AI is one of them. And in my modeling, when AI transitions to being in space, it ends up dragging up the entire space economy. So space mining, space manufacturing, and everything else gets pulled up to extraordinarily high values within a matter of just decades. So because of that, I think there are thinkers in every nation who know where we're headed, strategic thinkers, and they know about the importance of the moon. And so even though you don't hear a lot of talk about it, I know that that's what's going on in people's minds.
Yeah, the collateral damage thing is an interesting one to think about. So a lot of the things that are probably more prevalent in the news, or at least to the space curious people like Mark and I, we've heard things, about satellites in lower Earth orbit, the Kessler syndrome kind of thing, that there's a maximum amount of devices that could be put up there before they start messing with each other, and coordination is impossible. Is there another metric that's used to track how much stuff we can launch into the atmosphere, and when we would potentially be dangerously approaching that effect?
I don't think yet. There's not yet. Over the last 5 years, the number of papers on this topic have been growing exponentially. It's really exploding into a big concern for a lot of academic researchers, atmospheric scientists. The issue is not carbon. You can recycle the carbon from the atmosphere to create the rocket fuel so that it becomes a closed cycle and it doesn't increase the carbon in the atmosphere. The problem is you're depositing heat in the stratosphere, and that heat drives chemical reactions of the molecules that are already there, creating something known as NOx, N-O-X, which means non-stoichiometric ratios of nitrogen and oxygen. And that is a greenhouse gas, and it does affect globally the climate, but because there is very little circulation in the stratosphere, it has a dwell time that's very long before it dissipates. So right now we're well below the limit. There's nothing to worry about. But if we go to a launch rate of 10 launches per day of Starship, that might be around the limit. I'm just guessing because the papers are still pretty early. SpaceX is now talking about a launch rate that's even higher than once per hour. When you look at, they want to build 10,000 Starships per year. And if you look at what is the steady state launch rate that would be required for that production rate? And it comes out to like one launch every 2 minutes globally. 50 launch sites around the world pumping them out. So
I live in the UK. For the UK, there are trains which are not that frequent. There are underground metros which are not that frequent.
Yeah. So I'm not saying that rate is really going to happen. I'm just saying we're anticipating a time when we will definitely get above the limit of damaging the atmosphere.
That's why these conversations are so interesting to me, that we're able to look beyond the levels of where people are pointing to kind of see those cascading effects and potentialities. And there's a lot of really smart people working on all of this. Let's talk about another bullet that you mentioned you're really interested in and kind of figuring out in some of your research. So democratizing space were two words that kind of kept coming up. What does that actually look like in practice? Like, let's try to get something concrete and say, hey, it's the year 2045. You have succeeded in democratizing space somehow or some way. What does daily life look like for people on Earth, people in space? What's different? Like, let's have some fun with this.
Okay, well, the term everybody uses is, I think they call it fully autonomous luxury communism. Have you heard that term before?
No.
Yes,
that's the title for the show, Philip, I think.
Okay. Yeah, so the idea is that if you have enough robots and enough artificial intelligence, then they do all the productivity. And production of value is no longer scaled by population or by workforce. And so once you've decoupled economic production from labor, then you can scale it up to where we have the superabundance. But it does introduce these social problems like, well, who gets what? How do we guarantee that everybody gets a share of that? And how do we keep some people from using their control over the industry to dominate world affairs and shape the world in their own image? So the one of the things people talk about to solve that problem is democratizing that industry. If we need to make sure that the ownership of the industry is held by enough people so that politicians remain responsive to votes, so that the politicians remain responsive to the populace, so that democracy survives. If you only have a few people with the ability to produce 1 billion times the Earth's economic production, they could buy the politicians, they'll have the military they need. There's no way democracy survives in that situation. So I really think we have to democratize ownership of space. We need to make sure that equity is held, stocks are held by people all over the world. And I don't know how to do that, but that's a problem that I've been working on.
If you could basically have the one microphone and everyone in the world is listening who has influence, power, money, and they are 100% open and will say, Philip, I trust you. What do we need to do as step 1 and step 2?
Okay. Well, I'm directing an organization called the Stephen Hawking Center for Microgravity Research and Education. And this is what we're trying to tackle. It's a big problem. We don't imagine that we're going to be able to solve it all by ourselves, but we're trying to contribute to solving it. So we're creating programs for students around the world to participate in developing space tech and creating their own inventions, owning their own intellectual property, and then teaching entrepreneurship so that they can start companies and just get a piece of the pie. I went to Durango, Mexico, speaking to some schools, to colleges and universities. And the very first place I spoke, after my talk, we had questions. The first hand went up and the question was, this is really cool, but how can I be a part of this? And it was like a knife in my heart, because I realized at that moment, I didn't come with any answers. And so I stumbled through my answer. I decided, okay, tomorrow when I talk to universities, I'm going to need a better answer. But by the end of that week, every single college that I spoke at, that was always their first question. And I realized, okay, we have to create ways for people to be able to participate in space. The opportunities that exist right now are not adequate. And so we're trying to create a program that involves education and entertainment to make it fun so that it can produce revenue and become scalable so that we can reach a lot of people. But beyond that, I think the governments of the world should be investing more in space tech, in mining and manufacturing, in order to ensure that we get there sooner, because it is important for the health of our globe, environmentally. I guess those are the two main things I would say.
What are some cool examples of students or people coming into your program that are starting to riff on some cool ideas? I know they're not on launch pads yet, but what are some cool outputs so far?
Yeah, so NASA has a competition called the Lunar Mining Competition. It is annual. Right now, it's only in the U.S., but Caterpillar, the company that develops farming and mining equipment, they have been creating versions of Lunabotics in other countries as well. And then at the Hawking Center, we're trying to develop this in a few other locations as well to scale it up globally. But these competitions typically will bring in about 50 teams from colleges. They'll build their own robot. The robot is about the size of a bigger than a lawnmower, like a riding lawnmower, maybe a little smaller than that. And these students will raise their own money and they'll build their robot and they bring them to the competition. And during that week of the competition, the judges, like myself, take notes on the robots and we take a lot of photographs because we just had 50 prototypes delivered to us for free. Typically at NASA, we would only get enough budget to build one prototype of something per year. So this is a multiplier times 50. And from the competition, the students are trying all kinds of crazy ideas, weird wheel shapes. Like one wheel was shaped like a star where it was little convex patterns in the wheel so that it was compacting little humps on the ground as it drove. It was like 3D printing on the ground a track for like gears and cogs for it to drive in. And so rather than loosening the soil, it was actually compacting it and making it more traversable. We had another team that has a digging bucket that the digging bucket rotates to scoop up the dirt, but those kind of digging buckets always get rocks jammed in their openings because there's always a rock somewhere that equals the size of the opening just at the right size. And so they came up with this idea of using electromagnets. So every time they want to clear a rock, they release the electromagnetic, and as the bucket flips around, it opens up and lets the rock fall out. And then they turn the magnet back on and it goes back to the normal size again. A brilliant, simple idea. So we've actually learned how to build robots that won't get stuck in lunar soil just by evaluating the robots at this competition. It was a really complicated problem to solve. It took us several years of watching the robots and collecting data, but we finally nailed it. We know how to build robots that don't get stuck in lunar soil anymore. And it was because of the students. So if we could find a way to let the students own their IP and start businesses and benefit from it, I think that'll help the democratization problem. Think of it like this. This is an economic revolution we're talking about. We're no longer going to be limited to the scale of a planet. Instead, we're going to have access to literally billions of times greater resources from the moon and from asteroids. And also it's the robot revolution. It's a part of that. So we already have the robot revolution happening on the Earth, robots taking our jobs, AI is going to kill us all. But now put it in space and you have a billion times greater resources to build more robots and to build more factories. Okay, so this is a massive economic revolution that's going to happen. But humanity has been through several economics revolutions. The agricultural revolution 10,000 years ago, when they figured out how to use slave labor and animal labor with intensive agriculture to grow a lot of crops in one small area, which allowed for the birth of cities, but it had huge social problems. It resulted in slavery, serfdom, and it resulted in a lot of armies marching around the Mesopotamian river valley, wiping out each other's cities to try to get control over that new economic power. And then the Industrial Revolution, of course. We know all about the hard labor conditions in factories and the pollution that resulted. So every time we have an economic revolution, there's a period of trying to figure out how to readjust to manage this new reality that we're living in. So it's going to be that as well when we go to space.
But we've matured enough as a civilization to not allow the insanity of those two revolutions to happen for a third time, don't we? Haven't we?
I don't think so. No. Jeremy, I saw you shaking your head. I don't know if you were saying you don't believe it, but I don't believe it. I think humans have some very serious flaws in our cognitive processes, and those flaws come out too easily. We've learned over the years how to manage them to some degree. Like, for example, in science, we use peer review, and we rely on consensus building over time. And it works, but it's a slow process. It typically takes decades before scientists, or even a century before scientists will come to a really strong consensus on some of these questions. So it's not fast enough to solve social problems. In government, we've tried to develop democracy and republican democracies where we have division of power in various ways. These things help, but they're not perfect because the basic cognitive problems of humanity can always trick out the system one way or another.
Before we move into our final question, I want to talk a little bit about microgravity, because I think that's an important use case that gets highlighted, because you can manufacture things in microgravity allegedly more efficiently than you can without putting them in that state. So pharmaceutical manufacturing, semiconductors, fiber optic cable. Talk to us about what you're seeing in that world, and does that deserve the potential it's getting?
And is it true that you've done 450 parabolas?
I have.
So you know what microgravity feels like?
Yeah, I've done a lot of flying in reduced gravity aircraft. That was one of the great privileges of my career. I just been so lucky and blessed to be able to do these things. But yeah, I didn't really want to go on all those parabolas, but I was told to. And I was kind of a chicken. I didn't want the wings of the airplane breaking off when they're pulling 2 Gs, because you're flying in a 727. It wasn't really built for that sort of dynamic. They took all the all the seats out. They left the last 9 rows in the back of the plane so you could buckle up for takeoff and landing. But the rest of the plane is just empty space and it's padded because they're doing parabolas where you're going low gravity, and then they're doing the underside of the parabola where you're doing high gravity, and so you're going back and forth between floating and slamming hard against the wall, and then they do it 40 or 60 times, and then land, and then fly another day, do another 40 or 60 times. So we use it for testing technologies like I was studying how rocket exhaust blows soil and trying to figure out how does gravity affect the erosion rate. It turns out those were crucial tests. We wouldn't have solved the equation without those, because the cohesiveness of the sand sticking to each other is not really that evident in one gravity. But when you go to low gravity, the cohesive forces become more dominant. And we could see the erosion rate behavior at low gravity, and we're able to solve the equations. And so I have a theory now that's been published on how much soil will blow when you land on the moon. So that's an example of how those low gravity experiments can help us solve things. But when they talk about manufacturing, you really need to be in orbit because you need hours and days and weeks. I've heard of a few niche applications. There are several companies that have claimed they have a product, and they claim they have a business case for making it in orbit, bringing it back down to the Earth and selling it on the Earth. One example is fiber optics. Fiber optics are limited in how much data you can push through them based on the brightness of the light that you can push through, because you have to have a high enough signal to noise ratio to get a higher data rate. But if the light is too bright, it will cause the fiber to start melting, or to at least go into a non-linear regime of response to the light. And so what they found is that in zero gravity, they can grow these fibers with much higher purity, which allows you to push more light through them and more data through them. So the fibers become far more valuable as a product if they're made in space. The question is, can you make them in space and bring them back to the Earth? And, the extra cost less than the extra value. But they claim yes. So another example is making drugs in space. So I don't know the details of this, but for one thing, making protein crystals, if you're trying to understand the structure of a protein, one of the techniques is to grow the protein into a crystal, and then you bring it back to Earth and you shoot X-rays through it, and it allows you to study the shape of the molecules. I don't know if we even do that anymore with AI solving the protein folding problems. But in the past, we used to talk about making crystals in microgravity so that we can design drugs to interact with those proteins. There are several companies working on pharmaceuticals in space, like Varda Space, for example. And I don't know the details, but somehow they require microgravity to make these new drugs. Another example, this is a silly example, but when you shake up your Italian salad dressing, you're trying to mix the oil and the vinegar. You set it on your table, and like a minute later, they're already separated again. Well, in space, you shake it up once and it stays mixed forever. So you can mix materials that will stay mixed as the chemical process is proceeding.
Vinaigrette is the killer space application. Philip, if you don't mind, have a little bit of fun for our listeners before we close with the Kevin Kelly question. I'm going to give you about 30 seconds, and I'm going to say a space technology or something related to space. And I'd just like to give the Thinking on Paper listeners your opinion on the economic viability of this, or the likelihood of it happening, or what you think about it from a scientist's perspective. The first one, mining the moon for helium-3.
Yeah. I think that's viable. It's controversial. There are people who argue that it's cheaper to make helium on the Earth in nuclear reactors. But when you look at quantum computing and how quantum computing is going to scale up to gigantic levels, the amount of helium that you need for that cannot possibly be made on Earth. We're not going to be able to scale up the nuclear reactors fast enough. So that's one application of helium. Now, I have a conflict of interest. I am an advisor to a helium mining company called Magna Petra, but I have looked at this a little bit, and I do think that it is economically viable.
Hotels on the moon, or hotels in space in general.
Yeah, I think that's going to be a real thing. I think that'll be one of the early business opportunities. The reason why it'll be an early one is because there are customers. At first it'll only be very wealthy people who can afford to do it, but there's no coordination problem. If you can build the supply, then the customers will be there. So I think because of the lack of a coordination problem, it'll be an early business case. It's going to take more technology development. It's going to take some effort to make it safe enough. There's going to be issues about getting government permitting for these launches, where the government wants to look at the safety and are you marketing these without deceiving your customers. But I do think that's going to be a thing very soon. And in fact, I will predict that Disney World will have a hotel on the moon.
I like it. Asteroid mining, again, for helium-3 or other minerals.
Yeah, not so much helium-3. I've never heard of that being a something to go after on asteroids, but you could go after them for water to make rocket fuel. Also, there are platinum group metals in various types of asteroids. You can also just use it for bulk building materials, like making metal. If you're going to make gigantic antenna arrays in space, eventually it'll be cheaper to get the metal from asteroids. The challenge with asteroids is they're farther away than the moon typically, and so there needs to be more technology development. But I do believe that lunar and asteroid mining are going to be synergistic and are both going to be very real and important.
Space-based solar power and data centers in space.
Okay, I'd actually separate them. I would say space-based power, I'm a little more skeptical about that. I've looked at the numbers on it. I think that they will eventually become viable after we can make them in space rather than launch them off the Earth. So I think they will become a thing eventually, but there's other issues. One issue is geopolitics. Like if your entire country's energy is based on satellites, then you're very vulnerable to attack by another nation. And so I'm not sure if countries are going to want to put all their power systems in space like that. There's also issues with solar flares, which could knock out the electronics, which increases the requirement for mass shielding, which increases their cost because it's going to be more mass. But I do think they will become viable. It might not be for another 50 to 70 years when we can make them in space. But AI, I think that's going to happen really soon. My calculations show 10 years from now, it'll be cheaper to build a large data center in space than to build it on the Earth, largely because of the cost of delay from permitting. A very large data center might make $20 billion of revenue a year. And so a 2-year delay could be a $40 billion loss. Meanwhile, the cost of launch is coming down dramatically. These technologies are going to become more efficient. We're going to be developing lower mass radiators. And so as the technologies improve, costs come down. There's a crossing point where space is cheaper than Earth. And my numbers say about 10 years from now. I was surprised when Jeff Bezos, Eric Schmidt, and several others came out with the exact same number. They all said 10 to 20 years. I think 10 years is when it becomes economic. I think it'll take a little more than 10 years for the technologies to be ready. Now, Elon said 3 years. The standing joke in the space community is Elon time. You have to multiply by 3. So 3 years times 3 makes 9. That's about the same as everybody else is saying. But Elon is actually talking about putting inference rather than large data centers for training within just 3 years. I do think that's very viable. I think that he can adapt Starlink spacecraft into a distributed.
So sorry for that abrupt end to this episode of Thinking on Paper. It was so deep. It was so profound. It was so important that we have broken Philip Metzger's laptop. I kid you not. He's just dropped out because his laptop has overheated.
Oh, you gave me a cramp on that one. Holy.
Thinking on Paper broke his laptop. So we will wrap this up another time. For now, enjoy part 1 of our conversation with Philip Metzger. Join us for part 2 when we get into the Fermi paradox, Gerald O'Neill, and what it means to be human when civilization is space-based. Until then, listener, be disruptive, stay curious,
and keep thinking on paper.